our defense forces still importing the cold weather clothing because the goose down is not available in India. So this fiber can replace that thing also. So we are moving toward Atmanirbhar Bharat. SWOT analysis, we can see that a strength, zero input regenerative fiber crop, strong insulation and oil absorption property as proven by NITRA R&D, and growing industry interest that is shown that we are having a number of MOU with various industries. Weakness, it is a short fiber like a cotton, and lack of organized supply chain that is there, limited standards and mechanization is there, and fiber handling challenge. These are the challenge. If we go for opportunity, large sustainable textile market, wasteland utilization, if we start using wasteland, that we can generate rural employment also, and we can reduce the import of defense in various areas. Even you can get the carbon credit potential also if you go for this fiber. And threat is that competition from synthetic fiber and other natural fibers, supply inconsistency, ecological risk, and global IP competition that is out there. So policy support a strong enabling environment. We are having a national fiber mission to support that one. PLI and NTM support is there for R&D purposes. We are having different types of schemes of government that can be cultivation for worker. We can have that scheme. We can startup in a startup ecosystem for developing more product out of that. If we go for cost cultivation, milkweed for 7 years, approximately 2,37,000 per acres input is there. Gross return is 7.35 lakhs, and net profit you can have a 4.97 lakhs. And benefit cost ratio for our 7-year cycle is 3.09. That is one of the best you will get from other fibers. You compare with all types of hemp, flax, and you will see that it has a high BCR ratio. So now I come to flax fiber. Flax is an upright annual plant, and it is a natural biodegradable with high tensile strength, surpassing synthetic, sometimes surpassing the strength of synthetic fiber also. And it has a very good moisture absorption property. It provides cool and comfort in hot climate. Moisture wicking property is very good. It is UV resistance and naturally antimicrobial also. So if we go for a textile industry, that fiber, the obtained from stem can be used for making linen fabric. Linen is a strong, breathable and lightweight fabric. If we go for a flaxseed type of material, it is rich in omega-3 fatty acid, used in various types of product. The oil can be used for making a wood finishing, paint and varnishes. If you go for the other application in technical textiles, it can be used for composite, automobile, biodegradable product, insulation material, and eco-friendly packaging. Production and availability scenario, you see that India has a zero commercial flax cultivation. That is the point we have to note down, that 100% import dependent. Even the linseed cultivation is declining. That is the data showing that. India's entire fiber flax breeding efforts rest on the single variety JRF2, and released in 2015 by CRYGEF. And JRF2 yield 12 to 13 quintal of fiber per hectare with a fiber strength of 25.55 gram per tex. If we see the global production, it is a 3,34,000 metric ton 2024, with 93% concentrated in France, Belgium, and Netherlands. India import around 20,000 to 32,000 tons of flax fiber annually, CAGR 18.3 since 2013, but in the 2024 we reached up to 42,000 also. So we are the faster growing importer, if you see that in the flax. And so just I have given over there that we are 100% importing that. Last 2024 it was 42,000 we have imported, and we have also got some profit by exporting, and that is a $1.79 billion we have exported. Okay, ergonomy and cultivation, it grows 15 to 18 degrees Celsius in cool, humid and climatic. Most refined and in Europe, rainfed in Europe with low fertilizer, you can say less than 5 times fertilizer you require in flax. Tall, slender plants are densely sown, harvested in 90 to 100 days. Suitable regions in India include Himachal Pradesh, Uttarakhand, Punjab, Bihar, UP, West Bengal, Odisha, MP, and Rajasthan. Ideal time of sowing is October to early November. That is there. And recommendation are accelerate fiber flex breeding. Okay. CRYGEF. Okay. Collaborate with the European Breeding Institute like France and Belgium. Promote dual purpose linseed cultivation. Fiber as well as omega-3 rich seed. Conduct GIC based mapping to identify suitable flex cultivation zone. Develop pilot cluster in key states with 2,000 acres phase 1 target. Scale up the jute, rice and flex cropping system to improve farmer income and land use efficiency. These are the cultivation. I have already discussed that one, but the most important thing I would like to mention over there is sculpting. Zero domestic capacity we are having, and one sculpting machine is come out 25 to 40 crores per machine. That investment we require over there, because we are not having that type, and we have to develop it indigenously also, but at this moment we have to start working on that. And rating is also there, that now enzymatic rating is there, and 72 hours are required for that rating. So I would that Nitra pilot plant is also having that long fiber processing facility. And application and market, automotive industry, luxury textile, home textile, you can use that fiber. Production and finance scenario, you see that that I have already mentioned. Sculpting machine is there, and yield protection and land footprint 2,000 to 5,000 hectare Uttarakhand and MP. That is proposed. Processing cost 1.3 lakhs per hectare, yield 1.5 to 2 tons fiber per hectare. So these are the financial output, and in India also that fiber can be used for home textile. The market is at this moment 400 crores annually. Policy support, we require all the government support from here, and that is all similar for all the fiber, and that I am skipping over from here. And call to action, building nation, immediate priority, secure mini-mission third funding for NITRA COE infrastructure, finalize PP agreement for 2-3 sculpting unit, launch 500 hectare pilot cultivation in Uttarakhand or MP, complete BIS standardization, establish EU technology. If we see the cost of cultivation, that it comes out to be 2.28, and impact target, if you see the 15,000 tons domestic production by in 5 years, and reducing the import dependency 35%. Okay, sir. Hemp fiber is also there. It is the oldest one, and if you see that this fiber, I am just giving you a production landscape in India and global. At this moment, 1,200 hectare is being used for production of that fiber. It comes out to be 10,000 to 50,000 metric ton at this moment, and we are targeting 50,000 hectare, and that is within 5 years. And at this moment, 72% of that fiber we are importing. That is there, and most you can see that China is the one of the big player over here. And hemp strategical advantages, you can see already mentioned 1,200 hectare we are having, and 72% means 28% of domestic demand we are just fulfilling by using 1,200 hectares of land. We require 72%, we are importing 72% of fiber. Market potential is there. We can use that market. Global market is now, you can see that it is projected that in 2033, it will go up to 30 billion USD. So this is the right time we have to work on that. So ergonomy and cultivation, I am just giving you the key recommendation. Establish hemp processing center of excellence in NITRA with mechanized processing facility. Develop satellite center at NINFAT, and designate SIR, NBRI for hemp ergonomy research. support pilot project for enzymatic grating, launch skill development programs, provide 40% capital subsidy for mechanized hemp processing, promote cluster-based fiber processing infrastructure for value addition. This is the technological landscape and scaling challenges. India lack commercial scale facility for cottonization, enzymatic grating, and advanced decortication of hemp fiber. Technology transfer from established hemp processing regions such as China and Europe remain limited. Fiber quality is inconsistent due to variation in rating, harvesting, and post-harvesting, and quality. So the quality suffer, and so it requires the investment in R&D. No dedicated government funding program is available. So this is the market potential, and this is the important point that I would like to mention over here. NDPS amendment required. Current Narcotic Drugs and NDPS Act restrict cultivation to THC lower than 0.3%. So clear regulatory framework needed for industrial hemp. It should be work. According to that, the license can be obtained. We have to work with state level cultivation permits, seed certification standards, and THC testing protocol. So we can give 40% capital subsidy for machinery, MSP for framework 50 to 60 rupees per kg, and export promotion schemes. This all I already covered. Thank you very much.
Thank you so much, Dr. Parmar. And now I request the COE lead for Task Force 2, Dr. Anil Sharma, Director IJIRA, to kindly give a PPT and highlight the recommendations of the task force on the fiber, kapok, pineapple, and banana. Please. I would like to request you to kindly give your presentation in the time so that other speakers can also have 15-20 minutes to themselves.
Thank you. Sir. Okay, sir. ठीक है, sir. Bamboo fiber, we are second largest, but unfortunately, we are not in the fiber sector. Green economy is always available, explosive market is there, sustainability, beyond fabric, you can go to composites and others. This is the summary. Problems, constraints are that we have a process technology difficulties. We are not able to make bamboo fiber pure mechanically. We were able to make only viscose globally. So China is dominating. Our problem is we are fragmented value chains. Cultivation, processing, textile manufacturing, they are not in a chain. They are working as a silos. There is no skilled workforce specifically on bamboo. The technical knowledge is not there among the students, the industry, and there is no quality standards also on the bamboo fiber. These are the main constraints, ma'am. So the priority which has been changed is set up a pilot plant line and a skill pipeline together. Second is import the technology and licensing cell wherever is possible. Third is incentivize MSMEs to go for pulping and then value added. The important thing which I am going to say is that through pulping, you can make the fabric which is 30% lighter than cotton. And Japan is only making it, taking pulp from China. The samples are there. Unfortunately, I could not show at that time. I think this is the route we should look for. The third thing is, there is a possibility of a steam explosion also, but that has to be done at the pilot level. Once it is best verified, then we can take it out. Value additions, design, innovation is one area. Create centers and NID and NIFT, include them. Bamboo cotton is the best win because immediately your cotton mills can absorb it and blending can take place. Technical textiles is one area. Composites is very big area for us. And export ready markets are available because of the use standards. So these are the problem with the bamboo is there are 128 species. So you have to find out certain species where the fiber can be extracted, not the lignins are high. So these are 8 species which we have identified where we'll keep on working on it and trying to find out how much fiber can be extracted economically. Another issue is that the productivity in India is only 1 to 3 tons per hectare versus 30 tons per hectare in China. The problem is that we are not cultivating bamboo as a farmer. It is only in the jungle which is growing, and different species are growing. We are not specifying on a particular species. These are the areas which we have to work out, and the genetic materials like unlike China, which uses clonal plantation and superior mozo bamboo, which move fast. So these are the 2 areas which agriculturally we have to look into. If you see the revenue of the farmers, first 2 years no revenue, intercropping you can get 30 to 50,000 rupees per acre. Third year from 18,000 to 24,000. Fourth year 30,000, and from 6th year onward 2 to 3 lakhs the farmer can get. These are the studies which has been done in Nagaland by the National Bamboo Board and also economics. Direct employment 161 man days plantation per acre, and maintenance 30 to 40 man days per annum, and every job in plantation creates 3 to 5 jobs in processing. So this is the area of employment generation which can give. Now, internationally, there are 2 basically countries. One is in Netherlands, Bambuda. They make mechanical extracted fiber, and their capacity is today 160 tons per annum, which they are next year increasing to 600 tons per annum, and by 2027 and 28, they are going to 3,000 tons per annum, and they are entirely using it for lightweight composites. The another is Cobratex. This is a project which is going on in France, still not commercialized, but they have patented 2 technologies. So these are the 2 primarily which we can think about internationally. China makes lot of it, but mostly through the pulp route, and leaves it for Japan to make the fabric. Key challenges is viscose is 160 rupees, 170 rupees kg, versus these fibers are bit costly. Then seasonal availability of the bamboo, particular age only you can take. So this is another issue. Then lack of global standards on natural bamboo. Whether it is natural, whether it is viscose, nobody knows. So there has to be distinction between it. That's why the confusion between viscose and lyocell. These are the things which have to be identified. Once you label it, then you get the premium out of it. So India way forward can be process breakthrough, enzymatic mechanically. Fortunately, we have been able to do something up to the pilot scale level. Then blend the yarn. This is the challenge then. Then Northeast India as the bamboo fiber cluster, create that. Zero waste, use the 60% waste which is coming as WPC. You have seen the things here. So these are the things which you can think about. So you can achieve around 500 million USD export market by 2030. This is what is expected. Now, yesterday I was given some idea about 1 TPD. I'll just give 1 minute. That 1 TPD, we have established a pilot plant in Ijra. But if we have to go to 3 TPD, that means 1 ton per shift, then these are the changes which are required. So this will increase little bit of capex, but individually I feel that the more the capex you utilize, the better is ROI for you. So instead of making it in one ton, if you make it 300 kg, 300 kg or 500 kg, you will be using more capex. But even if you do 1 ton per, you still get around 63 rupees per kg profit. So this is rough calculation, but it has to be still validated. Now, I'll go to RAMI. We all know we have to become RAMI. We have to become first in India. RAMI is 90% is in China. But the problem is there is in China, which we can capture. Now, we know this is the strongest fiber, uses less water than cotton, 90% is with China, all stories are known. The problem is now that the China made a robust industry once centralized chemical industries, that model is now creating environment problem. So therefore, there is a global vacuum. They do not want environment problem created degumming process. So our goal should not be to repeat what the China has done, but to go one step ahead of it. And you see these statistics in last 15 years, China's 72,000 hectare cultivation has gone down to 28,000, 2.5 times down. And the reason is 60 to 400 tons per ton of REMI is the pollution created, which is creating the industries to close down there. And India, we don't have any commercial degumming facility. We don't have any fine spinning unit of the REMI. We don't have BI standards. We don't stabilize it. So Indian REMI has a higher gum content than China. So duplicating that technology is not going to help us. So therefore policy has to be that we move from raw fiber supply to processed fiber supply. Somebody wants saliva of particular length, we give to him. Somebody wants staple, we should give it to him. And once they are habituated to it, then we can move out of it, and then this chain will start. So fortunately, we have now microbial degumming, which can be translated to the farmer level. So that means farmer can get directly income out of it. And we also have a enzymatic rating also. So those processes are fortunately available with us, which in China are now 2 or 3 industries are adopting. So these are the issues which are required, that hybrid degumming process, I told you, and high yield seeds. So that the cultivation, that means R1411 Hazarika, Cryzef I think will give more details. This is one area, and the hybrid and the microbial degumming are the 2 center area if we want to grow REMI. So create pilot plant so that initially, if we don't have 15-20 ton at the maximum REMI, we cannot make any plant. So create a common facility or a pilot plant so that we keep on feeding to the industry, gain their confidence, and then keep on growing it. That means expansion, we can go from 600 to 5,000 hectares expansion, so that we get ample REMI, and the standards, create BI standards, and give some MSP to the farmers. So this is the priority actions. Because 70% is consume less water than cotton, so you have very strong EU ESPR validation. So that is the premium you can get. And you can have brands. These are all premium products. You can see in the stall. The specific modulation is so strong that it can replace partially glass fiber and Kevlar. So we recommend that ISRA and DRDO jointly program with MOT and MOD. And then ISRA, CITRA and ICMR also clinical trial do for surgical areas. These are the 2 high-end areas. Then automobile area is one, and cotton blaming is the fastest. So first, I think I skip it. So create semi-commercial pilot plant, that's first. Strengthen the growth that from Cryzef cultivation. Create BI standards. De-risk the farmer and launch India-specific brands. Okay, sir. ठीक है सर. Okay. Okay. अच्छा, सीसल की समरी सिर्फ इतनी है कि सीसल हमारे यहाँ जितना भी होता है उसकी कास्ट जो है एज कम्पेयर टू इंटरनेशनल मार्केट कास्ट बहुत ज़्यादा है. वो कॉस्ट इसलिए ज़्यादा है क्योंकि हमारा जो डीगमिंग हम करते हैं उसकी वो बहुत मैनुअल है. तो अगर उसको ऑटोमेटिक कर देंगे दैट कॉस्ट विल कम डाउन. दैट्स द फर्स्ट एरिया वी हैव टू अटेम्प्ट. सेकंड एरिया इज़ कि उसको एंजाइमेटिकली ट्रीट करें. उसको एंजाइमेटिकली ट्रीट करें. तो एंजाइमेटिक ट्रीट करने से वो फाइन होता है. तो रोप की जगह आप इसको फैब्रिक में यूज कर सकते हैं. सम सैंपल्स आर देयर. सर सर
अभी अगर नाइजीरिया में सबसे ज्यादा हो रहा है, अगर वहाँ का रेट क्या है,
सर
मोटा मोटी बताते हैं.
सर ओके
नहीं तो ये काफी सब लोग अगर देख देख करके एक एक स्टेप बाय बोलेंगे ना तो समरी आप लोग बोल दें।
सर रॉ मटेरियल की कास्ट जो है 450 टू 700 रुपीज़ पर टन है इंटरनेशनली, और हमारी जो है 1524 रुपीज़ पर टन आती है, तो वाइबल नहीं होता है। दूसरा इम्पॉर्टेंट पॉइंट है, इसकी लिग्निन को कम कर दीजिए। हमने लिग्निन कम करी है, जिसकी वजह से हम लोग इसको ब्लेंड कर पा रहे हैं, 6 पाउंड का यान बना पा रहे हैं।
फिर से कहिए कि इसका रॉ मटेरियल क्या है, इसकी कॉस्ट कैसे आपने कहा फाइबिलिटी।
सर इसका ये है, इंटरनेशनल प्राइस जो है वो $450 से $700 है सर, और हमारी है 1524 डॉलर पर टन, ऑलमोस्ट 4 टाइम्स ज़्यादा है सर।
4 टाइम्स हमारे यहाँ ज्यादा।
हमारे यहाँ ज़्यादा है
हमारे यहाँ इसलिए ज्यादा है
सर।
कि हमारे यहाँ इसके कॉमर्शियल वायबिलिटी पे कभी काम नहीं किया गया।
बिल्कुल सही सर।
अभी क्राइजेफ ने जो CSIR से हम बात करेंगे
सर
उन्होंने क्या इसके कॉमर्शियल मॉडल एग्रीकल्चर का एडॉप्ट करना पड़ेगा।
सर तो हाँ, इसकी यूटिलिटी ये है सर, इसको क्योंकि इसका लिग्निन अगर आप हटाते हैं एंजाइमेटिक डीगमिंग करके, ये 2 इम्पॉर्टेंट एरियाज़ हैं कि आप इसकी एंजाइम को लिग्निन को कम करें। यूटिलिटी इसकी ये है, ऑटोमोबाइल्स में इसका बहुत यूज़ है बिकॉज स्ट्रॉन्ग है। इंफ्रास्ट्रक्चर में
वो हटा दे अपना तब बोले।
ठीक है सर,
सामने रहेगा
ठीक है,
आप समझी
नहीं नहीं ठीक है सर, सॉरी। तो बेसिकली ये ऑटोमोबाइल्स में और फैब्रिक के अंदर बहुत अच्छा जा सकता है। जो लाइट वेट जो फैब्रिक मैं बता रहा हूँ आपको, उसमें सीजल का बहुत इंपॉर्टेंट पार्ट है पल्प की तरह। लिग्निन को आप कम कर दीजिए, दिस इज ए वेरिएबल प्रोडक्ट, दैट्स ऑल।
इसके जींस के कपड़े बन सकते हैं इसका और रेमी को मिक्स करके।
सर जीन्स के कपड़े आप रेमी तो थोड़ा कॉस्टली कर देंगे, जीन्स के कपड़े इसके और कॉटन में ही मिलके आपको स्पेशल जीन के कपड़े बन जाएंगे। दिस आई कैन अश्योर यू दैट द ऑडियंस। यस सर। हाँ, स्ट्रेंथ इसकी यूज़ कर सकते हैं, और इसकी लेंथ और स्ट्रेंथ को हम यूज़ कर सकते हैं लाइट वेट फैब्रिक बनाने के, जो जापान के साथ हम लोग डील कर रहे हैं इसके लिए। थैंक यू।
Thank you so much, Dr. Sharma ji. And we come to the third task force report, which had COE lead of Shri Prakash Vasudevan from Citra, and the fibers here are pineapple, banana, and kapok. Yeah.
Sorry. So, dignitaries on and off the dais, very good afternoon to all of you. I'll present the 3 set of fibers, banana, palm, and kapok, which was under the task force 3. And I'll present first an overview of these 3 fibers. World's largest producer of banana, India, whereas the fiber production is very tiny, less than 1% of the fibers are produced here. And globally, pineapple fiber, we are 6th largest, and we have a huge capacity here. Less than 2% is actually only converted into fiber, textile fiber. And kapok is concerned, we are very tiny. We are just 4,500 to 6,000 metric tons per year, whereas Indonesia dominates this with 70% of the world market, with close to 180,000 metric tons of fiber produced. Just an idea about the difference between these 3 fibers when compared to cotton. Pulp has got the highest cellulosic content. It is you can look at kapok, which is very light. It's only 0.29 to 0.35 grams per cc. So it's so light, and it's also a little shorter. And the cost of these fibers, according to the findings, it's actually they are much costlier than cotton. but they can be brought down with industrial scale manufacturing.